Our formula allow you to change a sine theta plus or minus b cos theta into r sine theta plus or minus alpha, or a cos theta plus or minus b sine theta into r cos theta minus or plus alpha. Notice that they are opposite signs. Next, I'm going to show you a couple of examples of how these can be used. First, let's look at the steps we need to take to use these formulas to transform something like this, 3 sin x minus 4 cos x, into the form of r sin x minus alpha, where r has to be greater than 0 and alpha will be between 0 and 90 degrees. To do this, we're going to use the relevant addition formula to write r sin x minus alpha as r sin x cos alpha minus cos x sin alpha. Now we're going to equate the relevant parts of the original expression to this new one. So that gives us 3 sin x equals r sin x cos alpha, and 4 cos x equals r cos x sin alpha. Simplifying these, we get 3 equals r cos alpha and 4 equals r sin alpha. Arranging, we get cos alpha equals 3 over r and sin alpha equals 4 over r. This is the first stage. Now we'll use these results with the trig identity tan alpha equals sin alpha over cos alpha. Tan alpha will be sin alpha, which is 4 over r, divided by cos alpha, which is 3 over r. This is the same as 4 over r times r over 3, which is 4 over 3. Alpha equals tan to the minus 1 of 4 over 3, which is 53.1 degrees to 3 significant figures. Now we found r, we're going to use another trig identity, sin squared alpha plus cos squared alpha equals 1, to find r. This gives us 4 over r squared plus 3 over r squared equals 1. Same as 16 over r squared plus 9 over r squared equals 1. This makes 25 over r squared equals 1. So r squared equals 25. And r equals 5 because we were told that r had to be greater than 0. Therefore, 3 sin x minus 4 cos x equals 5 sin x minus 53.1 degrees. We can use this result to solve 3 sin x minus 4 cos x equals 2, where x lies between 0 and 360. Using our previous result, this means that 5 sin x minus 53.1 degrees equals 2. Dividing by 5, we get sin x minus 53.1 equals 2/5 or 0.4. This means x minus 53.1 equals 23.6. Then if we sketch the sine graph, we can find that there's another one in the 360, 0 to 360 range at 156.4 degrees. Adding the 53.1, we get x equals 76.7 or 209.5. Let's recap those steps to find r and alpha with this new example of 2 sin x minus 5 cos x, which we've got to turn into the format r cos x minus alpha. So r cos x minus alpha is the same as r cos x cos alpha plus sin x sin alpha. Equating this with the original, we get 2 sin x equals r sin x sin alpha, and minus 5 cos x equals r cos x cos alpha, giving 2 equals r sin alpha and minus 5 equals r cos alpha, giving sin alpha equals 2 over r and cos alpha equals minus 5 over r. So tan alpha equals 2 over r times r over minus 5, which equals minus 2/5 or minus 0.4. Alpha minus 21.8 degrees. Sin squared alpha plus cos squared alpha equals 1 gives us 2 over r squared plus minus 5 over r squared equals 1. being 4 over r squared plus 25 over r squared equals 1. This is 29 over r squared equals 1, which gives us r squared equals 29. R is the square root of 29, which is 5.39. Therefore, 2 sin x minus 5 cos x equals 5.39 cos x plus 21.8 degrees.